All right, class. Scientific principles allow us to make predictions. We make predictions all the time in physics class, and we always use a scientific principle in order to get to the finish line, to answer the question. Sometimes we don't remember the name of the scientific principle, but I want to implore you to try to remember the names of these scientific principles. Let's take a couple examples. So let's take this scenario. We got a green ball moving to the right, 2 meters per second, and you have to make a prediction. How far will the ball travel after 3 seconds? Well, you might know that, okay, if I'm moving at 2 meters per second, and 3 seconds later, it's going to have moved 6 meters, right? 2 times 3 is 6. Well, what scientific principle is that? Well, if you want to solve this question, you really have to know about velocity, namely maybe the definition of velocity. Definition of velocity, that would be a scientific principle or idea or a concept. Knowing that velocity is how far you go in a certain amount of time. Another thing, a same way of saying the same thing is the scientific principle is your equation for velocity or your formula for velocity. Namely, velocity equals distance divided by time. And if the velocity was 2 and the time was 3 seconds, you cross multiply, these cancel out, and you end up knowing that the distance was 6 meters, just like we calculated it before. So what scientific principle allows us to make a prediction? Well, it's the equation for velocity, or the definition of velocity in this case. Let's take another example. We have to make a prediction. What is the acceleration of the box if pushed with 5 newtons of force? Well, this principle is actually a law. We call it Newton's second law. And his second law, he said that acceleration is directly proportional to the force and inversely proportional to the mass. That was his second law, but it's also in the form of an equation, but we say it as Newton's second law. And all you do is, the force on that box was 5 newtons, it said in the prompt, and the mass was 4, and so you end up getting a fraction. The acceleration is 5/4 meters per second squared. You could use that on a calculator. But what allows us to get this answer here, to answer that prediction question? Well, we use the scientific principle of Newton's second law. Last example. We have these 2 carts, they collide. What is the total momentum after the collision? Well, if we got this one car, P equals m times v, so the momentum of the red car is 3 times 2, which is 6. The momentum of the blue car is 2 times -5, which is -10. Add those together to get the total. We know that the momentum after the collision has got to be 4 kilograms times meters per second. So I solved the problem, great, but how did I do it? Well, I definitely needed the definition or the equation for momentum. I needed that, P equals m times v, but I also needed the principle called the law of conservation of momentum. Conservation of momentum. That was absolutely important. I'm not allowed to make this prediction unless I have this. The law of conservation of momentum states that the total momentum before the collision, which was -4, will equal the total momentum after the collision. So it has to be -4. Ooh, I forgot my negative. Boom. So always remember what allows you to make these predictions. And what do you say? You say, what allowed me to make this prediction was the law of conservation of momentum, which states that the momentum before the collision equals the total momentum after the collision. So you want to practice the physics language of citing your scientific principle. And this will make your reasoning and your conclusions just all the more succinct and academic sounding. So anyways, there you go.